So today we are going to discuss NFA to DFA conversion. So you know that NFA, it is you can denote NFA with the help of five tuples: Q, sigma, delta, Q0 and F. And you know the meaning of all these five symbol. You know that Q, it stands for a finite set of states. Sigma, it is input alphabet. Delta, it is a transition function. Q0 is the start state, and capital F, it is a set of final states, and F is a subset of Q. The main difference between NFA and DFA is the transition function. So basically, you know that the transition function uh, of DFA, as we have already discussed, it is uh, current state and input symbol, it get mapped with the next state, right? But in case of NFA, that next state is nothing but the power set of Q. So I mean, consider this NFA. Here you could see that there are three states, and you could find that there are two transition on input symbol 0 from state Q. So on input symbol Q, you are transiting to Q0 and Q1. Then from input symbol on input symbol 1, from state Q, you are transiting again to state Q and Q2 and Q1. And rest, you can see from 1 there is a transition from state Q0 to Q2. Then there is a self transition on input 0 and 1 on state Q1, right? So depending on this, you can design your state transition function. So this is your state transition function for given NFA. So here you could see that, as I told you, on Q0, on state, from state Q0, on input 0, you are transiting to Q0 and Q1. I'll show the transition diagram again, Q0 and Q1, right? Then from Q0 on input 1, you are navigating to Q2. So here you can see on input 1, you are transiting to Q2 from Q0. Then on from state Q1, on input 0 and 1, you are navigating to Q1 itself. So this is shown here in the state transition function. And from state Q2, on input 0, there is no transition, and that is the reason here it is 5. And from state Q2, on input 1, you are transiting to Q2 and Q1, and that is the reason you could see here two states. Now from this you can observe that from one particular input from a one particular state, there are more than one transitions. So you can that you can see from the entries, like Q0 state 0 input, Q2 state 1 input. So here you can see that on Q2, on input 1, there are two transitions on state Q1 and Q2. And from state Q0 on input 0, there are again two transitions, Q0 and Q1. So there is no unique next state for from one particular, on one particular input, and from one particular current state. So it is not possible to determine the next state, and that is a reason this automata, it is called as non-deterministic finite automata, or NFA. When you cannot determine the next state, a unique next state on one particular input. So you could see that in that NFA, here we were having three states, right? Q0, Q1, Q2. And I said that I already told here that the state transition function of NFA, it maps your current state at input symbol with the power set of Q. So what is the power set of Q, that we will see. So in Q, we have three states. So power set of Q will be this: Q0, Q1, Q2, Q0, Q1, Q1, Q2, Q0, Q2, and Q1. And one more is a 5. So here if you have three states in q, so power set of q will contain eight entries. 2 raised to 3 is 8, right? So you could count here. Here we have 8 states, and phi is called as a. Why this is? Here we can observe. Now you can see that here from state Q0 on input 0, we have transitions on these two states, Q0 and Q1. And from Q1 state on input 1, we have transition to state Q1 and Q2. Now Q0, Q1 and Q1, Q2, both you can find it in the power set, right? Both belong to this 2 raised to Q set. So that is the reason it is, we can say that the state transition function of NFA delta is nothing but the Q by M, and it maps to 2 raised to Q. And the entries in the state transition table of NFA are nothing but the sets instead of a singular entries as in DFA. The way in DFA, in each of the transition function, you could see here, I mean, in case of DFA, here the way here you will have a single entries, but in case of NFA you could find here you have a multiple entries, because there is no unique transition on any particular input, and that is the reason multiple entries you could find in one cell, whereas in case of DFA you will be having only single entry in the cell. Okay, so you know that NFA is represented with the help of these five tuples, and the main difference between NFA and DFA is in the transition state transition diagram. In case of DFA, here you have Q, whereas in case of NFA, it is a power set of Q. This is the main difference which you have to remember. So now if you want to convert NFA to DFA, we will consider the q dash is equal to 2 raised to q, because as it will be the set of states for the resulting DFA. So the state transition function for the DFA is denoted as delta dash q dash, and and here it will map your q dash and input symbol with the q dash, right? So we will see how it can be done. Okay, so Q dash will consist of all the states in the power set of Q, excluding phi, because we don't have any empty. It is not there in DFA that you don't have a transition on any particular input. Definitely, from every state on every input, there will be a transition to some state in case of DFA. So there is no chance of having a empty set in case of DFA, and that is the reason the phi is eliminated from the Q dash, right? So if we have a state like Q0, Q1, or Q0, Q2, Q1, Q2, or Q0, Q1, Q2, in that case, how it can be represented in DFA? So you have to consider these states having states having the multiple states. Say here you could see here in this particular state you have two different states. Here you have two, and in this case you have three. So consider these states, give input whatever 1 0 or a b depending upon your input alphabet, and try to solve it in this, that is in this way. So if you consider same example, so q0 give input 1, q1 give input 1, and whatever is their answer we have to find the union of that. So q0 on 1 it is q2, you can see q0 on 1 you have Q2, Q0 on 1, Q2, Q1 on 1 is Q1. That also you can see from here. So it is Q1, and then find the union of these two and you will be getting Q1, Q2. So likewise, you have to find the transitions from these states on the each and every input. And combination of the state is considered as a final state for the resultant DFA. That means if any of the combination of states you are having a final state, like here in this, if you have Q1 and Q2, if either Q1 or Q2, one of them is a final state in NFA, then this entire state will be considered as a final state, right? And later this Q1, Q2, though it is a one state in the DFA, you can label it to the single name. Like you can call it as a capital A, Q1, Q2, this state you can name is as a capital A. So instead of Q1, Q2, you can mark it as a A. So this we can see in the when we'll solve the problem. The things will be more clear. So in the given NFA, your capital Q is nothing but the Q0 and Q1. Then your input alphabet is 0, 1. Okay. And your capital F, that is the set of final state, is nothing but Q1. And Q0 is your initial state. So the resultant DFA will be, you can denote it as M dash. This Q dash, which is nothing but the final, which is nothing but a set of state of DFA. Then input symbol, it is same as your what we have in NFA. Same input symbol will be used. After that, there will be delta dash, which is nothing but the state transition function. For DFA, we will call it as a delta dash. Delta is for NFA. Then Q0 is again your initial state. The initial state of DFA and NFA is same. And F dash is nothing but the final set of states. Now here you know that here your input symbol in case of DFA is 0 and 1, which is same as your NFA, and initial state is Q0. Okay, then the power set, that is 2 raised to Q, power set you can denote it as, it is phi, then Q0, Q1, and Q0, Q1. Q0, Q1, Q0, Q1. And here you need to include the phi as a empty set. Okay, this is your power set. Now in case of Q dash, which is the set of states for DFA, this empty set is removed, and whatever is remain, that we have to consider in the considered in a as a set of states for DFA. Okay, now we have to compute the delta dash for DFA. So delta dash for DFA, when you are computing, then you have to consider all states of your Q dash and give each input from the input symbol to the to all the states mentioned in the Q dash, right? So delta dash for, let's say, the first state, that is nothing but the Q0 on input symbol 0. So for that, you can see the state transition function of NFA. So on input from state Q0 on input 0, there are you can see the transition as Q0, Q1. So here we have to write the same Q0, Q1. Now delta dash on Q0 again, but with input symbol as a 1. You know that in case of DFA, we will have a transition from each state on each input symbol given in the input alphabet. So Q0 on 1. So Q0 on input 1, there is a transition to Q1. This you can refer from the state transition function of NFA. Okay. Now the another state here you can see is nothing but the Q1. So we will give input 0 to Q1. So Q1 on 0 is nothing but the phi. It means there is no transition. So This is phi. Now Q1 we will give input 1. So Q1 give input 1. So Q1 on 1, you can see here it is Q0 Q1. Okay. Now again you have here Q0 Q1. To this again you will have to give the input 0 and 1. To Q0 Q1 we will give input as a 0. So what we will get, or how we will solve this? So to solve this we have to see delta. Delta, it means here we are referring the state transition function of NFA. So delta state transition function of NFA we have to refer here. So check the transition from input state from state 0 Q0 on input symbol 0. Then take the union. Then Q0 on 0. Then next you have to write Q1 on 0. And to find this answer, you have to verify, or you have to take the help of state transition function of NFA. So here from this table, you can see that Q0 on 0 is nothing but Q0 Q1. Union. Then you could see Q1 on 0 is nothing but the phi. So that we have to write. And its final answer, you could see it is nothing but Q0 Q1. Okay, now after this, to the state Q0 Q1, you have to give a next input as 1. And in the same way, you have to evaluate, right? And once it is done, you have to find if you are getting any new state. If you are getting any new state, then again you have to repeat the same process. And after doing this, we will get the final answer. And later we can convert it to the transition